signal program because then it will be halfway. So we can complete the second order systems. Okay. Now second order systems can be classified under this category: undamped, underdamped, critically damped, and overdamped. And there is something called as the zeta. This is something called as a zeta, and zeta is nothing but the damping ratio. This zeta is nothing but the damping ratio, zeta. And you know what do you mean by damped and overdamped or underdamped or undamped. Now here it is the nature of response. If it is undamped, means oscillations with constant frequency and amplitude, means the system will oscillate with constant frequency and amplitude like this. Here the frequency is constant and amplitude, this is the amplitude, that is also constant. So this is the graph for your undamped system. So it is oscillations with constant frequency. Frequency is constant and amplitude is also constant. The value of zeta, you will come to know what is mathematical model for this. So zeta is nothing but the damping ratio. So that is 0. The closed loop poles, they are purely imaginary. That is, they will lie on the imaginary axis. Then second is damped oscillations. Damped. Huh? So when do you call system is under damped? The oscillations are damped. That means what? They will slowly decay. मतलब जो अपना डॉक्टर का जो दवाखाना में जो दरवाजा रहता है, हाँ, तो हम लोग उसको खोल के जाते हैं एंड देन इट कीप्स ऑन ऑसिलेटिंग एंड आफ्टर सम टाइम इट कम्स टू stop, or the sing which is oscillating and after some time which comes to stop. So that is what is called as the damped oscillations or under damped system. So in this case the value of zeta is between 0 and 1, and the roots or the poles, closed loop poles, they are complex conjugates with negative real part, complex conjugate with, and this also I have shown you the different graphs here. Then critically damped. So here the response is pure exponential, critically pure exponential, and over damped here it is purely exponential. So the value of zeta, if it is 1, then the system is critically damped. यहाँ पे आपका जो क्लोज लूप पोल्स है, दे आर रियल, इक्वल एंड नेगेटिव, और हियर इट इज between 1 and infinity, and type of closed loop valves are real, unequal and negative. This has been taken from well Bakshi, this, like here it is now zeta is 4. So zeta is 4 for this particular system, which is there are two graphs, one is your continuous and another is dotted. जो dotted है that is zeta 0.8 and जो है zeta 0.4, so that is nothing but under damped. So here response is damped oscillation. Damped oscillation is after some time the system will stop oscillating, I said. Now there are some terms you need to understand which is given in this graph. So just have a look for a minute here. So this is a system which is oscillating, and after some time it achieves the stable state. This is my desired value, that is at 100%, and the system is reaching this after some time, and that time is Ts. So this difference is called as the steady state error. Now system is initially in unsteady state, grrr, grrr, like that. So the maximum value where it reaches, that is your peak overshoot, and it is shown by MP, and the customer or the user, he wants variation of the steady state value in some tolerances. So if I talk about say plus minus 2%, so this tolerance band is shown here. This is a tolerance band. Now here it is not plus minus 2%, 90% means it is 10%. Then this is the 50% value of the target, like say this is your 100%. So say if this is 5000 rpm, my spindle has to run at 5000 rpm, then this is 2500 rpm. All right, and this will be your 50, that is 10%. So to achieve that 50% value, like suppose I want 5000 rpm, so to achieve that 2500 rpm, what is the time required? So that is TD. What is the time required to achieve the 100%? So that is TR. And what is the time in which it overshoots the maximum value? That is your TP. And this is your TS. So we let us see each and every term. So this is your CT is nothing but the response, and this T is nothing but the instantaneous time. MP is nothing but the P go. So these are the definitions. Delay time, that is TD, that is this. It is the time required for the response to reach 50% of the final value in first attempt, and this is given by this relation TD is equal to 1 plus zero point 0.7 zeta upon omega n, where omega n is the natural frequency. It is the frequency which the system oscillates. Then you have a rise time, that is TR. This is your rise time, TR. So that is given by time required for the response to rise from 10% to 100% of the final value for overdam system. So here it is 10% to 90% for the overdam system, and 0 to 100% of the final value for the underdam system. Underdam system means system which is oscillating and then comes to end. So TR is given by pi minus theta divided by omega d, omega d, where this is theta is in radians and omega d is nothing but your dynamic frequency. You'll come to know what is it. Then peak time, time required for the response to reach its peak value. Okay. Or it is also defined as the time at which response undergoes the first overshoot. So that is your TP is equal to pi upon omega d. So how to find out the omega d? Omega d is find by this relation, that is omega n under root of 1 minus zeta square. Then peak overshoot MP, that is this value, MP, that is this value. So It is the largest error between the reference input and the output during the transient response. This is still the transient response. So what is the largest error? That is same. I want 5,000, and for a moment it has reached say 6,000 or 6,100. So that is the largest. So 1,100. That's your peak overshoot. Like even this happens during the our voltage supply. Sometimes you get a peak peak voltage. That is what is called as a peak overshoot. Surge, sudden surge. So as a control engineer, you have to control that surge or the overshoots, because that could be dangerous. That could be dangerous. Those peak overshoots or sudden surge can spoil the gadgets, can spoil the instruments. And then how to calculate the peak overshoot? That is MP is given by this relation. C of t and t is equal to Tp minus 1, and percentage of MP is given by this. Then setting time. So it is a time required for the response and to decrease and to stay within some specified percentage. That is the time required to achieve its steady steady state. Now this is your steady state. Okay, and this steady state you have the system has achieved at this time. That is what is nothing but TS, setting time. So that is given by this relation. So you have a time constant of the system. So you are familiar with this. That is given by this relation. T is equal to 1 upon zeta omega n, and Ts is equal to 4 into time constant. So time constant T is also defined by this relation. By the it is the time required by the system output to reach 63.2% of the final value during the first attempt. Now let us see uh, the problems on this. A unit step input is applied to the unity feedback system, for which open loop transfer function is given by this GS. Open loop transfer function is generally GS, and HS is nothing but the feedback. So find its closed loop transfer function. So what is the standard form of the closed loop? It is, a closed loop feedback system. So standard form is given by this GS upon 1 plus GSHS. So if I take a unity feedback, so how do I find out the standard form of closed loop transfer function? So GS is given by this relation 16 upon S S plus 8. So I'll substitute for that 16 upon S into S plus 8 into 1 plus this GS, that is S into S plus 8, and HS, that is 1. So this is equal to, you get this. So this is second order system. Order is 2. Now you compare with this second order. So in terms of natural frequency, the second order system can be represented by this equation. Cs upon Rs is equal to this omega n the whole square divided by this s square plus 2 zeta omega ns plus omega n square. So if I compare this and this, omega n square will be 16. So natural frequency will be 4. This is what is second question. So closed loop transfer function is this 16 upon s square plus 8s plus 16. Then natural frequency omega n, that is 4. Then damping ratio and dynamic or damped frequency, that is omega d. So that is given by this relation. So omega d is given by damped frequency is given by this relation omega n under root of 1 minus zeta square. Before that you need to calculate the zeta, that is damping ratio. So 2 zeta omega n 2 zeta omega n is equal to 8 if you compare. Now omega n is 4. So zeta will be 1. And if you compare the table, if you remember is if zeta is 1, then system is critically damped. And damp frequency is 0. That means what? As the system is critically damped, there are no oscillation and hence the omega d is 0. Since there are no oscillation, there will be no frequency. Okay, so you got all these four. For a system having transfer function, these are actually all university questions. 64 upon this. So for unity step input, determine omega n, zeta, omega t and time for peak overshoot, that is Tp. So again compare this now with your second order system, that is omega n square upon this. This. So omega n square will be 64. So therefore omega n will be 8. Two zeta omega n will be 5. So zeta you will get 0.31 and 0.31 is the zeta. That means if you look at this table, it is nothing but under damped oscillation complex conjugates. Right? So you can get damp frequency omega d. Time for the peak overshoot, that is Tp, is given by pi upon omega d. So radian upon radian per second, that is second. And these are the answers. Now a second order system is given by this relation. So find its rise time, that is Tr. Peak time, that is Tp, peak overshoot. Then setting time. If subjected to unit step input, and also calculate expression for its output response. Okay. So now this they are comparing with our standard form. Omega n square is equal to 25. So omega n is 5. Again now this middle term 2 zeta omega n, that is equal to 6. So substitute for omega n, so you will get zeta 0.6. Now theta is given by tan inverse of under root of 1 minus so and so. So omega d is nothing but omega n and this. So we get damp frequency also. Then Tr, that is rise time, that is the first thing. Pi minus theta upon omega d. What is theta? 0.9272. Then Tp, that is time required for the peak overshoot. So pi upon omega d, that is, then percentage Mp, that is by this relation, that is 9.48%. Percentage, that is Mp, I think it was not asked. Huh? So Ts, that is your settling time, that is this relation. Then response, output response, that is this relation. So 1 minus e to the power omega n, that is natural frequency, which is phi, and theta 0.9272, and then omega n, that is 4, sorry 5. Okay, so just substitute and you get the answer. Okay, so the response will be given in terms of time t as this ct is equal to. Okay. So this was your second order system ka formulas you have to learn, write it on a single page. Weightage for this is around 5 marks. Okay. But very simple topic. Okay. And then we can start with the single signal flow graph. Okay. So I'll just introduce you this signal flow graph. Like block diagram. So similarly you have this signal flow graph. Okay. So these are the some definition signal flow graph में, that is source node, sink node, chain node, forward path, etc. So what it is signal flow graph? It is a graphical representation of variables of a set of linear algebraic equations. So dependent and independent variables are represented by nodes, while relation, that is these are called the nodes. ये nodes है these. While relationship between nodes are represented by branches. This is your branch. And branch gains are associated with the branches along with the arrows. Okay. So source node is the node having only outgoing branch, that is known as a source or input node. So here x0 is a source node because it has only a outgoing branch. Then sink node. So sink node is the node having only incoming branch, that is this. It has only incoming branch. Now this or this cannot be a source node or sink node because this has incoming as well as outgoing branch. Then chain node, that is a node having incoming and outgoing branch. So that is your chain node. So x1, x2, x3, x4, these are your chain nodes. Then you have forward path. So forward path means path from the input to the output is defined as the forward path. So input to the output, this is your forward path. So now how many forward path we have? Like it is from Mumbai to Delhi. So how many ways are there to reach from Mumbai to Delhi? So let us see now here. So this is one forward path, that is x0 to x1 to x2, x3, x4 and x5. Okay, so then second forward path, that is x0 to x1, then x1 to x3, then x3 to x4 and x5. So this is your second forward path. Then your third forward path. So third forward path is x0, x1, okay, then x2, okay, then from x2, x3, and then from x3 it can go to x5 like this. Okay, so that is third forward path. So one is straight like this, another is like this, then like this and like this. Then third is like this and like this. And then fourth, x0, x1, x2. And what? Is there any fourth forward path? X0, x1 is one is like this, another is like this, then next is like this. Now this. Okay. So is there any more forward path to reach to x5? So it is like this from here, and then यहाँ से it has gone like this, and then this and this. So this is also forward path, but not this one. Okay, so you have to see that no node is to be traced twice. Then feedback loop. Feedback loop is nothing but a loop which originates and terminates at the same node. That is called the feedback originate. So now x2, x3, x4, x2, then x3, then x4, x2, x3, x4, and then x2. That is called the feedback part. No node is to be traced twice. Then self loop. Self loop is this. It has only one node. So T33, that is called as the self loop. And then path gain. Path gain is nothing but product of branch gains going through a forward path. So path gain for this x0, x1, x2 will be 1 into T12, then T23, then T34 and T45. It is the product of branch gains. So that will be given here. This is your branch gain T12. This is another branch gain T23, T34 and T45 and T33. Okay, so multiplication of all this, that will be your branch gain. Now T33 cannot be taken, okay, because we are considering this path x0, x1, x2, x3, x4, x5. So it will be only this. And there are some properties of the signal flow graph, so that we will discuss in the next lecture. ठीक है. Now weightage for this will be 10 marks. So from SFG you can draw block diagram, and from block diagram you can draw SFG. That is also vice versa is also possible. Okay. Yeah. Thank you. Any doubts?
Okay.
Okay. Fine.